All right, good morning and welcome again to Coffee Talk. Thanks for joining us. I'm your host, Neil Sass. On this show, we talk about soils and livestock and diversity, covers, no disturbance, and roots throughout the year. You know, no big whoop, just coffee talk. The big news this week, we're starting to see water in its liquid form once again. Feels like it's been quite a while. So as you start to transition from ice fishing season to turkey season or basketball season to soccer season or winter to spring, thoughts turn to seeing white snow changing to green cover crop fields in some areas, or maybe white snow changing to brown fields and brown runoff in other areas. And that's why we're here today, talk about these things. We've got an excellent lineup for today. Really excited to hear from our guests. So before we get going, please ask questions. There's a chat box. Use the chat box or raise the hand button, and we'll take your questions. So first up today, we have Chris Jones. Chris is an IIHR research engineer at the University of Iowa. He does a lot of work with water quality, water quantity, land use, cropping system, manure, nutrient management, and a whole bunch of other things. And he does a really great job, in my opinion, of visualizing these things with data. So I kind of started following his work after finding his blog, which I'm hoping he talks a little bit about today. So welcome, Chris. We're really glad you could join us today.
Okay, thanks, Neil. I appreciate the invitation. And so I assume you can see my slides there?
I'm not seeing them yet.
I had a issue yesterday with Teams also.
It's a little tricky. I have issues with it all the time.
How about now? Do you see anything?
I'm not yet. You found the share content button and then kind of pick whichever. Okay, something's changing now. There we go. I'm seeing your desktop now.
Okay. All right. So great. Thanks for the invitation. Yes, I work at the University of Iowa. IIHR, Hydroscience and Engineering, is an institute within the College of Engineering here. It's been here at the university for exactly 100 years. And so if you know Iowa City, it's operates out of this building on the banks of the Iowa River. We have about 50 PhD faculty and other researchers that out of there, and about 100 graduate students from all over the world. And so I'm a research engineer. I've worked here for 5 years, and as Neil said, I have a website, and I invite you to go there. I post all my slides, but I've been presenting a lot yesterday, and I'm kind of behind on that. So I don't have these slides up there yet today, but I'll try to get them up there in the next week. Yes, I do write blog posts, and I post those there, and I try to write something every couple weeks or so, but I haven't written anything in a couple months because I've been so busy. But yeah, you might find those interesting, and so please go there and check those out. And so what I do here is mainly is manage the university's network of water quality sensors, and this is one site here. We have 2 field staff that maintain the system. We have sensors deployed all around the state of Iowa, and our sensors are in blue there, the IIHR sensors. Most of these are funded through the Iowa Nutrient Research Center, although we have other funding sources, including the Carver Trust and some others. Then we also harvest data from USGS deployed sensors, and those are shown in green. And then we have some sites that are funded through the Iowa Watershed Approach Project, and those are in red there, and that's funding from Housing and Urban Development. And so at all the sites, we measure nitrate, nitrogen in streams, and then at a subset of sites, we measure those other parameters there that you can see on the left. And so this site here is on the Watsapinican River near DeWitt, Iowa. The sensors slide down through that PVC pipe into the moving river water. Then up on the bank, we have a dry box with a deep cycle battery in there, a data logger, and a modem, and then the whole thing there powered. This deep cycle battery recharged with the solar panel. And so we send data back to the university here every 15 minutes. And so we're generating an enormous amount of data, as you might imagine, 70 sites every 15 minutes. And so here's another site. This is actually up near Osage, the Crepe wetland there, near Osage, Iowa. This is the second largest Crepe wetland in Iowa. We have the inlet and the outlet censored. And so we've had one student get a PhD studying the processes in that wetland and the wetland's capacity to sequester nitrogen. And so that's been ongoing for several years. And so the first sensor actually was deployed in 2006. I worked at the Des Moines Waterworks at the time in the Raccoon River, just west of Des Moines on near Van Meter, Iowa, and you can see it there. And so this has been something we've been doing in Iowa for quite some time now. And so all the data streams into the website, what we call the Iowa Water Quality Information System. You go to the homepage and you'll see the sites there, and you click on a site and it'll give you the nitrate concentration, in real time right now. And then there's a lot of other things you can do with the website. When you click on a site, it'll delineate the watershed area upstream from the site. I should say, we do retrieve most of the sensors in the wintertime to prevent ice damage. And so there's only a few deployed right now, and we really start to get stuff back out there usually on around March 1st. And so if you go to the website today, you won't see this many sites, but there are some on there. And so there's a really excellent land use tool on the website. If you click on any spot in the state of Iowa, it'll give you land cover upstream of that site. And so this is the Iowa River watershed upstream of Iowa City. And so you click on that and you can see, 38% corn, 29% soy, and those other land covers. And so this is really useful for the work that we do and what others are doing. So I work closely with Keith Schilling, who's a state geologist, and we try to, publish original research using the data. And these are some of the topics that we've published papers on here the last 5 or 6 years. And so, again, most of it relates to nitrate, nitrogen, the contaminant hydrology of nitrate, nitrogen, but also some phosphorus work and sediment. And so I think you all know the consequences of this eutrophication here in Iowa. We have the dead zone down in the Gulf of Mexico, and we're not the only one. We have Lake Erie over there in the eastern Corn Belt in the upper left, and so we have drinking water issues related to this eutrophication of our water. And again, I'm sure this is nothing new for you guys. You know all about this. And so, this is a picture of the Des Moines River last summer. And so this is a container. I have some names blacked out, the label there, but this was the Des Moines River last summer in downtown Des Moines. And so, this nutrient issue that we have here is serious. And, we have a tough nut to crack here to solve this. And so I thought I'd present some data I've been working on just this week. And this looks at Nitrate loading for the state of Iowa last year, the 2020 water year, which is October 1st of 2019 to September 30th of 2020. And so I'm going to show you some data here. The purple line there shows how Iowa is divided between the Missouri and upper Mississippi River watersheds. All those watersheds there I have data for, and so we'll just look at some of that. And so when I look at the state in subset of the upper Mississippi and the Missouri, we can see in 2020 the nitrate load going to the upper Mississippi was about 435 million pounds. The yield in that area, 17.5 pounds per acre in total, and 27 pounds per acre per crop acre. And last year, our runoff in these areas draining to the east was 13 inches. The Missouri, land draining to the Missouri, we had a load of about 191 million pounds, a little lower yield of nitrogen, 17 pounds per acre overall, and about 23 pounds per acre on a per crop acre basis. And it was drier over there. We had a runoff of 10 inches. And so when I look at the individual watersheds for last year, the black there is the yield in pounds per total acre. The red is the pounds per crop acre, and then the blue is the runoff. And so you can see how that varies around the state. One thing that's been pretty remarkable over the last few years is this loss in northeast Iowa on a per crop acre basis. And so we can see there the Yellow River watershed, about 78 pounds of nitrogen lost per crop acre to the outlet of that watershed, which is really astonishing. And in fact, that is the only or one of the only watersheds in Iowa where the nitrate load increased from the previous year. We can also see up northwest Iowa, Floyd River, about 36 pounds per crop acre, with relatively dry, with only less than 10 inches of runoff, and so real intense livestock production in northwest Iowa. And so we see the Floyd River year after year having a very high nitrate yield. Oops. And so when we look at that within the context of the Mississippi Basin, the larger basins, the Missouri Basin, the upper Mississippi, and then the entire Mississippi Basin, over time, this is Iowa areas draining to the Missouri River. And so the red dash line is the fraction of the land that Iowa has in the Missouri River watershed. And so we have 3.3% of the land. We contribute about 12% of the water, but we can contribute about 55% of the nitrate. So the Missouri River would really have almost no nitrate in it without contributions from Iowa in some years. And that you can see there 2011, 2006, and 2003. The upper Mississippi, we have 21% of the land. We contribute 21% of the water. And we contribute about 45% of the nitrate. And then down at the Gulf of Mexico, we have 4.5% of the land, 5.9% of the water, and 29% of the nitrate. And so I think no big surprise here. We know Iowa is a disproportionate contributor to this issue with nutrification in the large basins. And so if we're going to solve this problem down at the Gulf, we're definitely going to have to get better up here in Iowa. And so how much nitrogen leaves Iowa? Well, we look at this as a 5-year running annual average to kind of smooth out the year-to-year variations. And the red there is Iowa in total, and right now we're losing about 425,000 tons every year. And that value is about doubled since 2003, the running annual average. We can see there in blue, areas draining to the Mississippi have increased about 72% since 2003, and then areas draining to the Missouri are increasing really far rapidly than the rest of the state, and that's likely because of conversion of pasture in western Iowa to row crop over the last 25, 30 years, and then intensification of livestock, especially in northwest Iowa. And so I've done quite a bit of work with mass balances for nitrogen, and this is the state of Iowa, and there's a lot going on here, I recognize, but the wide bars are the inputs, and so the dark green there is commercial, the orange is hog manure, the darker orange is beef, and then we have dairy, light green is fixation from soybeans, gray is poultry manure, and then the narrower yellow bars are the grain nitrogen, how much is leaving in the grain. And so we can see that, the inputs are, increasing. I mean, it's not mysterious here. We've seen increased crop yields, yes, but we're also seeing the inputs increasing. And so the surplus, the difference between the yellow bars and the yellow bars and the wider bars is in the red line there. And we know about 32% of that surplus makes it to streams in Iowa. And so we've really, in my estimation, kind of gotten away from, this input management as a strategy, to solve this. And we focused more on, the edge of field treatments like wetlands and bioreactors, and then, of course, cover crops and some other things. And we've kind of really drifted away from the importance of rates. And so, I would say until we can solve this mass balance problem, we're just never going to be able to solve this issue with water quality in our streams. And so one time somebody asked me, they said, "Are you the guy that said we're not going to soil health our way to better water?" And the answer to that is yes, I did say that. And when I look at these percent changes since 1999, river loads, nitrate loads have increased 83%. Okay. At the same time, we've increased inputs 36%, but we've only increased the grain nitrogen, what's harvested in the grain, 27%. And so this is exactly what we would expect from an ecosystem where we're intensifying it. We're trying to squeeze every little last bit of yield out of this landscape, and the negative consequences of that, in this case, the river nitrogen, are going to be disproportionately large compared to what we're getting here in terms of yield. And so again, I want to focus on this surplus. I mean, we know for a certainty that the surplus, the inputs, the massive inputs that exceed the outputs in the grain nitrogen, correlates very, very strongly with stream nitrogen. This is northwest Iowa, or this is western Iowa, a paper we published a couple years ago. My surplus here is the commercial nitrogen plus the generated manure nitrogen plus the nitrogen fixed by soybeans, and subtract the grain nitrogen. That's on the x-axis. On the y-axis there, I have the flow-weighted average nitrate concentration in the stream. And so we see this surplus explains about 80% of the variation between watersheds in terms of stream nitrogen. And so, the Rock and the Floyd River are out here on the right. And of course, that's where we have real intense livestock production. We know for a certainty that in these livestock dense watersheds, that farmers are applying more nutrient than they are in watersheds where we don't have dense livestock populations. And so our nutrient strategy here in Iowa, it's our main policy instrument for improving water quality. These are the practices that we are eligible for cost share with the state to reduce nitrogen loss to our fields. And, we don't have a lot of soil health strategies here. We have the cover crops, of course, and the living mulches, but, in my mind, much of the nutrient strategy has been focused on edge of field treatments. And, to talk about the surplus again, I say this a million times, I just do not know how you ask the taxpayer to fund these edge of field treatments while you give farmers license to do whatever they want with inputs. I just don't see that as being a sustainable strategy. Now, how long can that go on? I don't know, maybe a long time, but I just don't think that's a good formula for improving water quality. And so as we talk about soil health, I think, we should also be cognizant of what is going on out there. And so, we had this paper in Nature Sustainability published by these Iowa State folks, and basically advocating for an intensification of drainage across the state of Iowa. And of course, I think we all know it's gotten wetter, and we need to to drain more and more and more to get the soil conditions optimized for corn and soybean. And so what does that do? And so we basically are advocating diminishing soil organic carbon with this intensification of drainage. And so how is that going to square with what we're trying to do with soil health? And so all the soil health ideas are great ideas. I really am an advocate for that, but I just think we have to be realistic here on what the capacity is for this soil health stuff to improve water quality. And I'm just a little dubious that it's going to produce the water quality consequences that we want. And so this graph here shows something I did with the 2020 data. This is the watershed share of the nitrate load, the statewide nitrate load, and I divided it by its share of the statewide runoff. And so if a watershed had 10% of the nitrate load and 5% of the runoff, then the value would be 2. And 1 would be the statewide average. And so we can see here, the Floyd River there, northwest Iowa, it would be our worst watershed according to this metric, at above 2. And then, second worst would be the South Fork of the Iowa River. And all these ones with the red arrows are ones that have a real high density of livestock. And so, with the nutrient strategy, we really did not address livestock very much. And so a real question in my mind is, can we continue this intensification of the hog industry and really expect to achieve our water quality goals? And, I just would say, no, we can't. We're going to have to, try to get our arms around this livestock stuff. And of course, a great way to build soil organic matter is with manure. And manure is a good fertilizer. We all know that. But we really have to come to grips with the rates that are being applied in these manured watersheds, because this is really having a consequence for water quality. And Iowa law right now, the master matrix system and the manure management plan formulas allow for nitrogen to be applied at the old yield goal formula, which is 1.2 times the expected yield. It allows for really excess amounts of phosphorus to be applied when we apply according to the nitrogen rates. And so I think we really need to revisit the master matrix and the manure management plan formulas, because we really license farmers to over apply nutrient. And so I'll just finish with this slide. This is something that's gotten a lot of discussion. I never could have thought this thing would take off the way it did, but what I did was I looked at all the animals in Iowa on a watershed basis, and I converted their waste to a human equivalent, and so these are the effective human populations we have living in our watersheds in Iowa. And so, Des Moines, we have the drinking water issue. And upstream of Des Moines, we essentially have the city of Chicago, Tokyo, Paris, and then the states of Alabama and Oklahoma and Rome. And, is it reasonable to think that Des Moines is ever going to have good water, when we have this sort of intensity of production going on upstream? And so, I'm not against manure. I think we really need to give this a good long look of, how intense can we make this livestock production here and still hope to have any chance of achieving our water quality objectives. So I'll end on that, and happy to answer any questions.
Thanks a bunch, Chris. Yeah, if anyone has any questions, go ahead and pop them in the box or ask. Am I the guy that said we can't soil health our way out of this thing? And I've been doing soils for a while, and I fully understand soils is a thing that people don't understand well, and this soil health thing's been around a few years. And, we basically follow our 5 principles, and as I was looking at your nitrogen reduction practices slide that you have, I do think that a lot of those practices fit into our 5 principles. The nitrogen management really does fit into the minimize disturbances. A disturbance can be physical like tillage, but it is also chemical, so a synthetic fertilizer would be considered a disturbance. So, I do agree we have a ton of issues there, but I do think it does fit into our soil health principles, and it's something that we work on, difficult challenge quite a few times, but, and then the other things too, the cover crops, the live roots and mulches and perennials and extended rotations. I've seen some stuff of yours, about the change in land use from longer rotations to the corn bean system we're in now, and that's, like you said, it's a complex problem, and that's a part of it as well. So I do not see any questions, Chris. If anybody has any last minute ones, let me know.
Hey, I asked about the water. Hey, I asked about the water yield. Is that inches per acre?
So no, it's just inches total. And so what we do, we like to compare watersheds in terms of discharge, but watersheds are different size, right? And so the discharge of the Des Moines River watershed is going to be enormous compared to the Yellow River watershed. And so what we do is we take the total water volume at the outlet and we divide it by the watershed area to get a water yield. And so like a watershed, might have 30 inches of rain, right? If we had rain gauges scattered throughout the watershed and we would average the rainfall, we might have 30 inches of rain. And so expressing the water yield in terms of inches, helps us relate one watershed to another and relate it to precipitation. So it's 10 inches. It's like if 10 inches of rain fell all across that watershed and it all ran off, that would be 10 inches of runoff.
Question here, Chris. How valuable is it to soil health to move away from anhydrous ammonia to other nitrogen sources?
Well, I mean, we know that anhydrous is toxic, right? We've known that for a long time. And so I think, so I should tell you, I'm not a soil scientist. I am a chemist. But I think we all know that anhydrous is pretty harsh way, right? And so I think it goes without saying that if we got away from anhydrous, we would have more living things in our soil.
I agree. Yeah, that anhydrous is like a bomb went off, at the applicator, and it kills everything. So
yeah.
One last one I think we'll take. Just curious what the process is to relook at the master matrix. Does that have to be voted on by our legislature? How does that work?
Yes, so the master matrix would have to be a legislative rewrite. I think a lot of people, realize the master matrix, needs to be revisited, and that includes, a fair amount of people in agriculture. But the livestock industry also knows that if we restrict application based on rates, if we lower the acceptable rates in the manure management plan, that will in fact constrict the industry. And so there's just no doubt about that. And so, we see areas of Iowa where, we really just don't have more land to put manure down, especially northwest and then north central like Hardin County. But we can still permit confinements there. And so, how's this going to work? And so I think, instinctively people across the political spectrum know that we need to revisit it, but it's going to be really hard to change it.
There's one more here. I guess I'm kind of curious. Does estimated producers apply 30% over what is needed for N? Did you say 30% was applied or 30% of over application is reaching streams?
So yes. So about 32% of the surplus reaches the stream on average. And that varies a lot across the state. And so let's say they apply 300 and there's 200 removed in the grain, the surplus is 100. So we know about 30 pounds of that will reach the stream. And this tends to be higher in tiled landscapes. So.
Perfect. Well, Chris, we really thank you for coming on this morning and sharing your work. This is some great data, some great visuals. I shared your website here at the top of the chat box, so if people need more info, they can go there and find stuff. But we do really appreciate your time. So thanks for coming on and joining us this morning.
Okay, well, I'll just say a lot of people get mad at me over those blogs. So if you read them, that was mad, sorry.
That was going to be my question for you, and if you could go quickly, what has been the response of those and Twitter? Mostly mad?
I probably no. I mean, I get less blowback than what most people would expect. I'll just say that. So I'm still sitting here.
We're glad you are, Chris. Really do appreciate you joining us. We'll let you get back to your breakfast. Okay. Enjoy your Friday, and thank you.
Thanks for the invitation.
Gotcha.
All right.
You're welcome to stay on if you want. Next up, we have. Sure. All right. Thanks again. Next up, we have Lisa Holscher. Lisa, if you're on, go ahead and start sharing your stuff. I kind of lost track of who's been on and off here.
Hey, Neil. I hear
something.
There you go.
There you are.
I had my headset pulled up so that I could drink the rest of my Diet Coke because, you know, I've already had 3 lattes and I apologize for everybody, but so you go. So
it ought to be entertaining. It ought to be entertaining this morning then. Lisa is the director of the Conservation Cropping Systems Initiative in Indiana. I chatted with Lisa the other day. She has a wealth of soil health, cropping system experience. She's really fun to talk to. I'm feeling she could talk to us all morning if we had the time, but we're bringing her on today to talk about her work and CCI's work with the Root Project. So welcome, Lisa. We're glad you could join us.
thank you. Thank you for having me this morning. If you want, you can go ahead and start that PowerPoint. So I don't know that I'm a wealth of soil health experience. I just get to hang out with people who are a wealth of soil health experience. You know, like some cats that you may already know, like a Barry Fisher from NRCS. Even though he's retired, he's still going to be around, believe me. He actually has one of our virtual field day kits, and I'll get to that in a little bit. There's my contact information. That's our website. Twitter feed, I do the Twitter feed. I really try to keep it very topical if you want to follow along with that. One exception might be this morning, celebrating 100th birthday of a retired district conservationist who actually was inspired by listening to Hugh Hammond Bennett on his Carolina farm. So, I mean, there's little bits there. The Facebook feed,
Cool.
I stay away from. I stay away from Facebook like the plague, leave that up to our program managers, and they run that. The bottom of the screen, and you'll see this throughout the few slides I've got, that's our mission, improving soil health on Indiana cropland. That's it. That gives us what we do. It's mostly outreach and education, but let me talk just a bit about what CCSI is or who we are. So you want to hit the next slide. So we are not an organization. We are not a 501c3. We are not a government agency. We're a program of what's called the Indiana Conservation Partnership. And this is a true partnership of these 8 agencies and Purdue University. I used to say, and actually I still say, my job is kind of like herding cats because we cover all of these partnerships and a host of other partners out there. And I hear it regularly is, how do you do this in Indiana? How did you put this partnership together? You know, it started in the 80s, in all honesty, when there was a lot of infighting and financial issues. And these groups came together and said, okay, we have to work together. And so it was made official, gosh, I think about 10 years later. There's actually some signed documents. And so all of these groups work together. Now, when I say that we are a program of them, I mean, and we don't reside in any one agency, I'm officially an employee of the Indiana Association of Soil and Water Conservation Districts. Our conservation agronomist is officially an employee of Purdue Extension. And so it gets kind of interesting, but it works as long as we all keep on the same page and our same goals. And just to kind of give you an idea of some of the impacts of that, let's hit the next slide. So these are our cover crop acres. We do a tillage and cover crop transect every year. It's usually led by the State Department of Ag with NRCS, SWCD staff all participate. So about 12 million acres of cropland. And for the past several years, we figured we've got about 1 million acres of cover crops, give or take. It'll be more interesting this year because the transect was delayed a little bit. So I think we may actually pick up some acres because of green up in the springtime, being able to identify some of those fields. But the real takeaway on this slide are the program acres. That's not just EQIP and CSP. That includes Section 319 watershed grants. That includes what we call Clean Water Indiana grants administered by the State Department of Ag. These agencies all pool their information, and they have signed agreements to pool their information to really get a handle on what's being done on the land. And even if you dig into like the State Department of Ag's website, our nutrient reduction strategy, and where we are with that, where we are with loads. That's a compilation of practices that have been implemented across that whole partnership. So it's enabling us to really track pretty well what each of our partners is doing. Of course, there's still some holes there, and just like any wide partnership, there's always going to be issues, but the key is that we're really working together. So, and I could talk about the conservation partnership all day too, but let's talk a little bit more about CCSI and about what we actually do. So let's go to that next slide, please. So outreach and education, that's our world. We do trainings, we do field days. In normal years, we would materially participate in 50, 60 workshops or field days or conferences and reach about 5,000, 6,000 individuals. Now keep in mind, we are a staff of four paid people, and a host of volunteers and our partners from field staff from all those agencies and NGOs. But even this year, after March 18th, we participated in a single in-person event and 2 hybrid events, one which was a field day and one which was, we call it the 3-day soil health training. I think you would call it the NRCS soil health for Midwestern field staff, same kind of, same training. That's it. But we still were able to reach some 4,600 people in 2020. Since CCSI's inception, we probably reached about 3,700. And when I talk about its inception, that's a 10-year period. That's how long we've officially been around. Now, CCSI had its genesis back in 2003 with Barry Fisher, formerly with NRCS as your, sorry, Neil, I never can remember the job titles, but soil health region director or whatever it was. He started CCSI as a 205J, an EPA grant, and called it the Conservation Tillage Initiative in Indiana. So, we've got some really strong foundations there. Anyhow, back to what we do. Field days, field days, field days. That's the upper left corner. The upper right corner of your screen, that is the 3-day training. And actually, if I look at that, I think that's Barry standing there. And it's not just, the trainings are not just for NRCS staff. If you look at the people in that soil pit, the person closest to us, that's Simon Kafari with Purdue Extension. The next person, can't remember if he was still with FSA at that point in time, but now he's with NRCS. And then the young woman leaning forward is actually from an SWCD. So we try to really train all of our staff so that we are all talking the same language. And that's really made a difference in getting conservation on the ground. Having that consistent language across extension educators, across NRCS, SWCDs, State Department of Ag. We do some other kinds of outreach as well. We do a regular podcast. That's Who's Your Ag Today actually produces those for us. They're an independent group and have a network of I don't know how many hundreds of radio stations they produce their content for, sell it to across Indiana and Michigan. So we do those a couple a month on soil health topics, soil health individuals. That gentleman on the right there is Rick Clark. Some of you may have actually heard Rick, a farmer out of northwestern Indiana, doing an interview there. So our podcast, we really try to keep very conversational. Typically, it's a farmer plus somebody else. So it may be an agronomist and a farmer. And we try to keep it very topical as well. So those have worked very nicely. Bottom right-hand corner of your screen, something we started this year, and it's virtual field day visits or virtual shop visits, virtual farm visits. That's actually Paul Yassa out of the University of Nebraska. We broadcast live. He had slides that he used to complement what he was doing, and he went through planter setup on that John Deere row unit, and also their international planter. Those have surprisingly worked very nicely for us, and we're reaching a very wide and varied audience. If you get a chance, if you get a chance to look at one of those, I'm proud of them, and they're just a little bit different. Going to be doing one hopefully this June, July with a guy out of Iowa, Lauren Steinlegge. I think a lot of you may know Lauren. We've been texting back and forth about doing something on his relay cropping. So we're going to continue this even when we can go back to in-person meetings, because it's something that's really, we feel is really going to augment what we're doing. So to what I'm really supposed to talk about. Let's go to the next slide. And a lot of the things on the prior slide came out of this one question of, wouldn't it be cool if? That's how the podcast started. That's how the virtual field days or virtual shop visits started. A lot of you have probably seen this. It's prairie plant rooting depths, rooting diagrams, and Stephanie McLean, State Soil Health Specialist with NRCS, just a passing comment one day last winter, said, you know, I saw this banner at this conference and it was full size of all of these prairie plants. Wouldn't it be cool if we could do that with cover crops? I thought, yeah, we can do that. Not a problem. It was a bit of a problem. Finding source material actually took a long time. And it was actually Stephanie who finally came up with the source material. Let's look at that next slide. Out of a university out of the Netherlands. And let's pause here for just a little bit, because if you get a chance to look these folks up, WUR.NL, they have an amazing library of all of these sketches of a wide variety of plants. Some of them have a little bit of top growth, but most of them are really concentrating on the root growth, what those roots looked like. And those were all done, gosh, the mid-20th century. So it may not be completely accurate to the 21st century, but it's a start. And I spent a lot of time digging through those archives, trying to find every cover crop that we could. And that's our source material, these hand-drawn images of as many cover crops as we could find. Now, let's take a look at that root project. This is available for download. This whole poster image, there are 3 other smaller, we cut them down to size so that people could print them out as posters. Those are all available for download. And the other thing about these is they're vectorized, meaning that these images that we have, the raw images, can actually be blown up to full scale or larger. And that's one of the things that we do want to do, is take a couple of these and do like vertical banners. And if we can ever find our source material for corn and soybean and wheat roots, I think I've got wheat, but corn and soybean roots, we can do some side-by-sides, full size of these cover crops. The SARE program, Sustainable Ag Research and Education Program, is actually going to be using these. You'll see them in some upcoming publications on cover crops. So they're getting use all over the place. When we put these on our website, and you keep in mind, we are small. We're a small footprint. Within a week, we had some 400 unique downloads from our website alone, all over the world. Universities, from the best I can tell, all over the world. Japan, China, New Zealand, Australia, India, Bulgaria, I think Czechoslovakia, the Czech Republic, South Africa, Nigeria, Egypt, Netherlands, Germany, France, UK, Chile, Argentina, Brazil. You get the idea. I mean, even a university out of Iran. It's humbling. And one of the first people to pull this down and actually respond was a gentleman by the name of Dr. Ray Weil out of University of Maryland. and I think a lot of you may have had to go through soil sciences and used as textbook. Very much appreciated these diagrams. We are working on trying to pull together some slides of cover crops mixes. So where you might have an oat radish or annual ryegrass, brassica mix that people will be able to download and use in their presentations. We don't charge for these. They're available to the general public. They are not to be used for commercial profit, but I think that they are being used as intended for education to show people what these roots look like. So to find these, let's have a look at that. This is our website. There's a lot more stuff on here than just the root project, but if you go to our website, the Do tab, that actually will get you to register for events. The Learn tabs where you're going to find podcasts. Let's hit the next slide, because this is our tools and resources. So on this slide, you will find not only the root project, you will find some resources for landowners, so our video library. So all of those virtual shop visits and webinars that we've started doing, as well as a photo library. Everything's available for download and reuse. And that's really gets to the heart of what we're trying to do. It's just improve soil health. Our target is Indiana cropland. Everything else we feel is really pretty much a bonus. So if you ever need some images for a presentation or something, go ahead and check out our library. When you download them, there will be a reference for who submitted them. All we ask is that you give credit. Most of them came from our soil and water conservation districts or NRCS, and that's all we ask. Give the appropriate credit. So yeah, go ahead, end it. I don't know, Neil, do you want to, I sent you that video of Jim Horman and me and Dave Brandt and Roger Winning.
Yeah, let me see if I can find it here. While I'm looking, Lisa, one question that I had, you mentioned corn roots and bean roots and other crops, and how rooting systems compare, and every once in a while we hear about tile lines getting plugged with cover crop roots, and I've had to answer those questions, but it really makes me think like, okay, well, a corn is a way bigger plant than all these cover crop drawings. Why isn't corn plugging tile roots?
So I'm really lucky. I get to not only work with folks across conservation partnerships, but also I have a really deep phone book of those top farmers that you may go and listen to. And some of the farmers that I work with are actually tile contractors as well. And we've had some really good discussions about roots plugging tile lines. And what we're finding, well, it's usually an issue with the tile. So maybe as they were plowing them in, they hit a rock or something, and so the tile collapsed a little bit, got a little bit of an egg shape. But one of the other things that we're really seeing is a bigger problem is, well, as big of a problem is snap-ins, where you're running from a lateral to a main, and those snap-in connections, they actually, they go into the tile that you're snapping into just a little bit, and it's just enough that you're catching things as they're moving down the line. If you think about like a bridge where you might have a log jam, or you might see a bunch of stalks being caught, it usually starts as one's getting caught. So one root, and then another, and then another, and then another, and then eventually you have a plug. So that's one big thing that we see regularly. It's the tile and how it's working. But the other thing to remember is the fact that these roots are growing throughout the season. And in a normal cropping system, you may have roots growing in that field, or traditional, I should say, that field for 5 months out of the year. But when we add cover crops, especially those overwintering cover crops like a cereal rye, those roots are going to continue growing even throughout the winter. And so you have more time, more and I'm losing my words here, but because the roots are there, there's more opportunity for those tiles to be plugged. So that's a lot of what we're seeing. I know that Eileen Kladivko out of Purdue University and Barry Fisher, and I can't remember the third gentleman's name, out of Ohio State, I believe, wrote some publications. And if you do like a Google search on roots and tile line in Purdue University, you can pull up some of those publications. And then you have the peer reviewed or the official version that you can hand a farmer or somebody. But
perfect.
Yeah.
Thanks for that answer. That's a tough one. We're running a little tight on time here, Lisa. There is a question or two in the chat box for you. If you can find that and answer them, we'd certainly really appreciate that. But thanks for coming on and sharing your information about CCSI and that root project. I was one of those early 400 or whatever number of downloads. You know, as soon as I saw it come out, I downloaded it and got it hanging on the wall here. You know, and I see those roots of annual ryegrass, especially, and think, man, that's really a powerful, you know, root system. How are we going to get more annual ryegrass here in Iowa? So, you know, that's my constant reminder. Every time I walk in and look at my wall, I see that. So nice job, Lisa. Nice job, CCSI. We appreciate your time this morning, and thank you.
Thank you very much for having me. See y'all.
Thanks. Next up, we have Tessa Roth. Tessa, if you want to start sharing your stuff, if you have any. Tessa is a resource conservationist from the Vinton resource team. Tessa is great to work with, eager to tackle all kinds of new challenges. She gives a dynamite soil health and rainfall simulator presentation. She did one this winter in the snow. So today we have Tessa on. She's going to be talking about the hidden half of nature. So take it away, Tessa.
Okay, hey guys. Let's see here. So I don't have any slides or anything, just a couple things about this book, The Hidden Half of Nature. It's written by David Montgomery and his wife as well, and Vinton. So the book is comprised of a couple different topics throughout it, mainly like the history of agriculture and the science behind the inputs, their own gardening experience, what they've seen, and then also and ended up getting cancer. And so it kind of dives into the microbiology and the actual human biome. And so it's actually a really interesting book. It's a pretty easy listen. I listened to it over audio. But sometimes it got a little long-winded about the true science behind microbiology. It was a lot on the human microbiome, and kind of as I was listening to it, I was like, you know what, for Pete's sakes, like, can we get back to like soil health? Like, that's what I'm really interested in. But it wasn't until they kind of got up to the 1970s and 80s that he finally started discovering more about microbiology in agriculture. So it's actually an interesting twist, you know, as humans were, you know, maybe more interested in medicine or interested in how our bodies function. So naturally we have more research based on, you know, what we encounter as human in our natural processes. So it's an interesting pairing. If you start to think about your body as a holistic system, and how what you put into it is going to affect the health of it, well, that's going to kind of mirror the soil as well, right? Like, it's also a system, and that microbiome that occurs in that soil is going to affect the health of that system. So just a couple of my key takeaways that I kind of liked about the book. So microbes each have their own niche. So we used to think like microbes are everywhere, right? But is it really that they're everywhere, or microbes do a certain purpose and they are a part of their own ecosystem, contributing to the whole of the habitat? So that's pretty interesting. And when we think about that, let's think about what we're actually feeding. So we can think about, all right, what are we feeding ourselves to kind of feed our microbiome? And then when it comes to soil as well, all right, what are we doing to actually, feed that soil and the microbiology that comprise that system as a whole? So it's a good read, or listen, however you like to do your books. But I like the pairing of the sciences and the history behind, something that we don't see, so it's hard to fully grasp. So it's just interesting. Yep.
Yeah, kind of like I said on Chris's thing, soils is something a lot of people don't see, and microbiology would be even a smaller fraction of that. So it is a hard thing to grasp. So where do you download it from when you listen? Is it just like I'm still a reader, I'm old school.
Yeah, no, you're fine. So there's a couple different ways you can. I downloaded it off of Audible. If you're an Amazon Primer, then there is a fancy thing that you get 2 credits for Audible for a month. So I downloaded this one, and I downloaded Gabe Brown's book. And I'm gonna cancel my subscription within the month because I'm cheap. But that's a way to get 2 free books. And then also, depending on your local library, like there's some books, like I have Libby. It's a library app that kind of links to your library card. So if you can actually find a library that has good books, that's a free way that you can access. You basically have a loan for like 21 days, and you can kind of download some books. So I've done that too.
Tessa, you sound like a soil scientist.
Haha, that's a joke. Oh, man.
Sign up for something and cancel it before you get charged.
Oh, okay, yep. I'm cheap, but I'm as cheap as the rest of them, I guess.
There you go.
Yeah.
The whole gut microbiome, human health thing, anyways, for me, as I learn things, and look at where our country is going, we were really concerned with population growth and feeding people and stuff all these years. Now as our country looks at healthcare costs, and other issues, I do think, healthy food, gut microbiome, all these soil health things are interconnected and are going to play a bigger role in the future. So I think, David and his wife are certainly probably ahead of the game on all of this. I think there's a lot to be played out yet, but I think it's going to be a bigger factor going forward. So nice report, nice comments.
Yes.
I think it's great stuff.
Yeah, thank you. And one thing too that I kind of liked, so they discovered this all on just doing it in their garden. And so there's something special about just trying these things out for yourself, and just asking good questions and just trying to find the whys behind it. So when we think about sometimes soil health, like it can be like really overwhelming, right? Like I'm in no way, I know that there's definitely some NRCSers that are like they actually look in the microscope and they can, actually tell you what these different microbes are, and that's definitely not me. But it's interesting that you basically make it for yourself, right? So if it's something that you're interested in learning about, it's something that you can certainly try out for yourself. You don't have to own, 500 acres in order to further your education on these processes. So,
Tessa, that was a perfect segue. The next coffee talk that we're going to do in 2 weeks is called Soil Health in Your Backyard. And I am going to be soliciting requests from anybody that wants to share something you've done in your backyard, if it's cover crops, if it's compost tea, worm juice, rotating crop rotations. Maybe you have livestock in your backyard. I know there's some chicken people out there or other things. So Tessa, you read my mind. Nice job. But that's going to be the topic for the next one. And I'm hoping to get enough presenters just from our staff, just from Northeast Iowa. So I'll be soliciting a request, sending out an email here probably next week, and hope to hear from many, many people. So with that, shoot, I went over my time, but I do thank everyone for tuning in today. I was trying to keep track of who was on. I think at one point I counted over 60 people. So appreciate you all tuning in on a Friday morning. Looks like it's going to be a nice day, and hope you enjoy it and hope you have a great weekend, and we'll chat again soon. Adios.
Thanks, Neil and Tessa.